Guys, and today, welcome back to another topic of colloids, which is a part of engineering chemistry series that I'm giving. And today, we're going to be studying. If I give you a little bit of overview of what we are going to study, we'll be studying introduction to coagulation, and then methods of coagulation, and we'll go then after a very important rule, which is very exam favorite, which is Hardy-schulze Rule. So let's get let's get to the studies. And first thing is that what we need to know, what is coagulation. Coagulation, as I've told you before, it is the process by which fine dispersed particles, obviously colloidal particles, come together to form larger aggregates, then eventually settle down. You can see here from the visualization, these colloidal particles are coming down together and they create precipitate, and they're settling down together, and this process is known as coagulation. Normally tiny particles never settle. That's why they start to stick together, they get attached to each other, and that's how they create or form bigger particles. Now you can say that if both of them are positive, how are they able to attract and stick together? Well, what happens is that they discharge, they release their charge, and they become neutral, and then they settle down. So from the mere definition, we can see that coagulation is defined as the precipitation. I hope you know the English terminologies, because you have to understand the basic, what is precipitate, what does aggregate means. So you don't want me to explain those. Coagulation is defined as the precipitation of colloids by the removal of the charge associated with the colloidal particles. We've studied two kind of colloids before. One of them is leophobic, another one is leophilic, and leophobic creates colloid by removing charge, and it creates colloid by removing charge and the layer of the medium as well. Then the by next one. So if I give you extra information about coagulation, B, why do colloids remain stable? Colloid particles usually carry electric charge. Same charges repel each other. This repulsion prevents particles from coming close and settling. And if I tell you why coagulation is important, uh, in many cases we have seen the usage or application of coagulation. One of them is water treatment. When you treat water, trying to remove its turbidity, you have to use coagulation. And another one is textile waste water treatment. We can see it in the food industry, paints, rubber, pharmaceuticals. So there is a lot of application of coagulation. I hope you would study them by yourself. These are pretty theory-based studies. Up next, we're going to be studying the methods of coagulation. Explain this. This would be a way to destroy colloidal stability. What happens is that the colloidal particles migrate to opposite charged electrode in an electric field. When we take a colloidal particle, it could be either negative or a positive particle. If it's positive, it will go to the negative electrode, and if it's negative, it will go to the positive electrode. Here we can see that the positive is going towards the negative electrode, and the negative is going towards the positive electrode. Thus, the colloidal particles get separated from the colloidal soul. The particles are discharged, and when they reach, if suppose the negative ion went to the positive, and he will release his electron, the extra electron that it has, and it will become a neutral component. So, what happens if I tell you step by step is the electrolyte releases ions in solution. Opposite charged ions neutralize the charge on colloidal particles. Once the charge is reduced, the particle now can come closer and the coagulation occurs. So if I tell you what happens here is that if you take this, suppose this is a negative colloid, it goes to the positive part and it releases electron. And from the definition of mere coagulation, we know that coagulation is the process where the precipitate or the settling down of the particles are created by the removal of the charge. So that's how it releases its electron, this negative colloid, and turns into a neutral particle. And a lot of neutral particle, when they come together, they create precipitate. That's how coagulation happens. And this is only by the addition of electrolyte, only by electrolysis process. So this is, I hope you understood it properly. And the next one is coagulation can be affected by boiling and freezing the soil as well. When you heat the uncooked proteins, you put heat, they create a long chain, long networks, and they come together and they settle down to create precipitate. That's how they coagulate with each other. Some examples would be if you put heat to liquid, it comes down to a solid precipitate. When you put heat to egg, the entropy increases, the entropy increases. So it starts to coagulate. What's entropy? Entropy is it is a it is a term mostly used in physics, and it is the disorientation of things in a pattern. So when the entropy increases, like the coagulation also increases. Even in the slides we can see in boiling the electrolyte absorbed by the salt particles is reduced and the particles are coagulated, and in the freezing process the dispersion medium is removed. Since there is no dispersion medium, what happens is that in terms of boiling, the electrolytes that you put, suppose it's KOH, it gets absorbed into the medium, dispersion medium, the particles absorb them, and it happens in terms of boiling. But when we consider freezing, what happens is that we know that in the freezing process, the dispersion medium is removed, and we are only left with the dispersed particle, which are found as precipitate. That's how you get coagulated particle. And the up next thing is by adding another another colloidal solution. Suppose in a colloidal solution there is only FeOH3, then you put this in the solution. What happens is that when something is positive and we put something a negative colloidal particle, just a disclaimer, how we can know whether a colloid is a positive colloid or a negative colloid. I've given you a chart in the previous video. If I take you there, is this a positively charged colloid? This a negatively charged colloid? You can memorize them, or rather, you can remember the important ones. So what happens is that when two different polar colloidal particle come together, they the positive and the negative attract each other. In this process, the total solution get mutually coagulated. Coagulation of a solution may be done by adding another colloidal solution containing particles which carry charge opposite to the charge of its particle. And this together, they come down together and they create coagulation. For those of you who still haven't got the main idea of coagulation, I would explain it again simply for better understanding. Coagulation is a particle. Suppose this is a particle. Some of them are positively charged, some of them negatively charged. Now, if they're positively charged, all of them, then they will by nature repulse each other, and they'll never settle down. They will never create precipitate. They will never do that. So what happens when you discharge them by any method? We are studying the methods now. What happens, they come down together and they create a dense precipitate, and this process of creating a precipitate is known as coagulation, and that is the key idea here. And in the fourth method, we can see that by adding solvent, this method is useful for the precipitation of hydrophilic colloids. Hydrophilic colloids are colloids that love H2O, that attracts H2O. If solvents like alcohol and acetone, which have affinity or attraction for water, are added to the hydrophilic colloids, the colloidal particles are coagulated due to dehydration. If we see the visualization, suppose this is a lyophilic solution. Lyophilic solutions are solutions that attract water. So what happens is when you put alcohol there, uh, the alcohol just creates the alcohol. When you put alcohol there, the the particles are firstly surrounded by water molecule, and the reason for that is they're lyophilic and they by nature attracts water. But but what happens, due to having water surrounding them and it creates a layer, it repulses each other and it doesn't precipitate. So how do you prevent that? We put something that also attracts water, that has affinity or attraction towards water. And what can be those things? This can be alcohol or acetone. Alcohol is something like that, and acetone is also an aldehyde or a ketone, obviously. Sorry, that's a ketone, and ketone is like this. So when we put, this is alcohol, this is acetone. Sorry, it's in college chemistry. I forgot some of them, so I gotta remind myself. So when we put them into the water, they create hydrogen bond because they have affinity towards the water molecule, and thus this layer around this particle, the H2O particle, they vanish, creating hydrogen bond with the alcohol that we have put here. That's how they get coagulated together and they create a precipitate. That's how we get coagulation. And the third last one is by adding electrolyte. We know how it happens. Lyophilic particles are easily coagulated by the addition of an electrolyte. The colloidal particles absorbs the ions of the opposite charge to represent on a particle. I think if I easily explain that to you, suppose this here is a positive colloidal particle and we put an electrolyte like KOH. What will happen is that we get two part to KOH, and the negative part and the positive one, they will neutralize each other, and that's how they will create precipitate, which by definition is known as coagulation. The process is known as coagulation, to be very specific. The charge of the particles is now neutralized, resulting in the reduction of repulsion between them. Consequently, they coagulate. That's what I said. So this was the 5 parts. I think it's done. I hope you understood. After listening to my video, I would tell you, if you don't properly understand, you should listen to it more and more. And one of the common questions and feedbacks that I get is that I should make these videos in Bangla. First of all, there are a couple of reasons why I make them in English. First of all, is to improve my presentation in English. And secondly, as university students, we compete with the world, not just in Bangladesh. We compete with the world. We compete with someone studying at MIT, someone studying at Harvard, and we gotta compete with them. We have to be like, we have to make ourselves compatible with these things. We have to learn to take lectures in English. I'm not saying that it is a must, but I think it's a very good practice. So, as I'm hoping that these videos are not for college students, especially for university students, for just the basic understanding. The problem with us university students is that if anything is detailedly structured, we can study them, but we just have to understand the basic idea. So that's what I'm trying to give you here. After that, what I would suggest is that you should research on this topic. By research, I don't mean you have to put out articles. By research, I mean you have to go depth into each topic so that you can get enough context around the topic. Thus, you'll be better able to explain and answer in the exam. So that was a suggestion from my part. And up next, we have got an important topic, which is this is the visualization of what happens when we add electrolyte. I hope you understood what happens. The positive and the negative part, whatever is needed based on the charge of the colloidal particle, we use that and they coagulate together. And up next, these are you may wonder why I have put them. Well, I have told you the study style that I have. After understanding a topic, I try to get a detailed view of the topic. So these are those detailed things. These are extra information. If you want them, you can study from here or you can find them on the internet as well. So up next, we've got the Hardy-schulze Rule. It is very important for the exam as it has a unique name, or it is named after the science. It is named after the scientist, obviously. And so the main concept of this rule is that the greater the valency of the oppositely charged ion, the greater its coagulation power. What it simply means that the precipitation action of ions on electrolyte depends on two things: whether a solution will precipitate or not will depend on two things. One of them will be the sign of the charge. The second one will be the valency of the ion. So let's repeat. If we suppose we have here one positive, we have two positive, and we have three positive ions here. So by definition, the coagulation power would be the highest in aluminium, as it has the highest amount of charge. If I simply write you down the rule, that would be easy for you. The rule simply means that the coagulating power of a solution is proportional to the valency of the counter ion. This is the absolute basic rule. So the explanation of this rule is that colloidal particles are charged. Suppose here is a negatively charged colloid. So if we try to put some electrolyte here, the more positive charge it will carry, the more it's going to neutralize the negative charge. Listen to me carefully. The more positive charge your electrolyte's going to carry, the more it is going to neutralize the negative charge in the solution. And the more neutralized it gets, the more they're going to come together and stick, because the repulsion among them will be gone. And that's how they create that's how they cause the coagulation. And obviously the important notes are the only oppositely charged ions matter here, because if there is negatively charged colloidal